Atlantis Computing webinar. End of VDI as a second-class desktop. Go persistent, use antivirus, enable search, and stop tuning. We have with us today Jeroen van de Kamp, CTO of LoginVSI, and Chetan Venkatesh, CTO and founder of Atlantis Computing. We're going to start off with Jeroen, who's going to take us through some of the current state of the union of VDI based on the Project VRC research, as well as internal LoginVSI testing that talks a little bit about the performance impacts of enabling different components of a virtual desktop. And then we'll have Chetan talk about the storage performance and its impact on user experience. And with that, I'm going to turn it over to Jeroen, and we can start the webinar. Before we get started, we will have a copy of the presentation available for everybody, as well as a recording of the webinar for those who were not able to make it that will be sent out automatically after the webinar. So, Jeroen, go ahead and take it away.
Thank you. Well, I'm Jeroen van de Kamp. I'm the Chief Technology Officer for LoginVSI, but I'm also Chief Technology Officer for Login Consultants. And some of you might know us from the Project Reality Check publications that we have done over the years. So it's interesting. We always did a lot of research about can you virtualize on the server. We did a lot of research about is it possible to tune VDI and in what ways and virtual desktops to get the best performance, because that capacity comes not for free in the desktop environments. There's a lot of things you can do. Now, the cool thing is that we did that for a couple of years. We've done many publications, and by the way, you can download those publications at www.projectvsc.com. These white papers are free, and you can see all the best practices and research and comparisons that we've done. The interesting thing is that last year, in October 2012, we started something completely different. It's called the State of the Union survey for VDI and service-based computing. And basically, we did not do performance research, but we basically asked all our community to participate in a survey. The survey was done by almost 1,000 people, and actually 660 people completely finished this survey. This in itself was quite a feat because there were many questions in there. Some were more business approach, like why are you doing VDI? But there were also technical questions in there. Overall, the survey represents more than 1 million hosted desktops. So we added all the desktops in more than 1 million. And in total, more than 5 million people work for the organizations that have participated in the survey. About 73% of the survey participants were IT pro, and about 27% is IT executive or sales, but non-technical. Now, we don't have time to go fully into the details of the survey, but they give us a really interesting view on how currently VDI is being deployed and executed. There are a couple of really interesting questions, and I just want to highlight a couple because the reality is right now, if you look at VDI, we first had to learn our industry that for many organizations completely underestimated the impact of VDI. They regarded it as to be the same as desktop server virtualization. But of course, one of the major bottlenecks that you have within VDI is storage I/O and I/O capacity, storage capacity. Now, so let's review some of the questions, because you know the majority of the VDI community is fully aware of that I/O is and storage can be an issue, and it has a high impact on user experience. And the reality is we also do a lot of tweak and tune. So one of the questions is that we ask is, okay, do you actually use stateless VDI? The interesting thing is that when you talk and you go to conference and you talk about VDI, you see that there's a lot of talk about using persistent VDI. Stateless VDI is nice in many ways, but it's one uniform shared image, and there are some also management challenges there. Now, interestingly, when we ask, do you actually use stateless VDI, 35%, 37% to be exact, of the participants said we absolutely do not do any form of stateless VDI. We only have persistent personal desktops that we give to our users. So still 63% of the participants said they were doing stateless VDI. But of course there are many ways to do stateless VDI. You can have it only for a small percentage of your desktop or for a large percentage of your users. Now we asked how big of a percentage of total desktops is actually stateless. And as you can see, about 36% have only a minority of their desktop being stateless, so there's only specific use cases. But interestingly, there's also still a significant portion in which a lot of organizations have a high percentage of their desktop being stateless. Now the reality of stateless desktops is that when you look at it from a user perspective, maybe it is it's working okay because it's using a shared desktop and a shared desktop image that is centrally managed. But the reality is for many VDI users it does have a different user experience because it doesn't make any sense to install personal applications within a stateless desktop. So there's quite a high number of users and organizations out there that put out stateless desktops because they give maybe a better performance or as a higher manageability. But in many cases users probably prefer maybe also stateful desktop because it's a much more personal experience. Now another interesting question is, we know that VDI is not easy when it comes to storage. Of course Atlantis is out there that changes these paradigms, but for many years we've been talking about it, presenting about it, and there's a lot of discussion about storage when it comes to VDI, and justifiably so. So we also asked in the survey, who of you actually did a dedicated design for VDI workload? This is interesting. 41%, 42% said they have a dedicated storage solution, specifically bought and provisioned for the VDI. So their physical storage infrastructure is dedicated for desktop virtualization. About 32% is just using the standard storage solution. And either that's a good thing or a bad thing. In many ways, in many organizations, you see actually when just use the standard storage solution, that doesn't work for big environments. You immediately run into all the I/O problems that you typically see with VDI workloads. What's interesting is there's quite a substantial percentage of participants that have 25% that actually they know that VDI have very special requirements when it comes to I/O and disk and storage, but they do share the storage subsystem with other workloads like server or database applications. Interesting to see that if you were to ask this, of course, 3-4 years ago, a very large portion of VDI was in standard solution, and it would be a typical best practice now to have actually dedicated storage for VDI. The interesting thing is, if we move forward later into Atlantis, that maybe you don't need to have a dedicated storage solution only for VDI. Maybe you handle the I/O with Atlantis. Now, there's also a lot of talk about you need to do local storage because local storage is very cheap. You can do SSD, and so we asked participants, are you doing local storage for VDI? And actually 70%, more than 70% is still do VDI using shared storage. That also makes sense because, especially when you're doing persistent VDI, it is much more manageable to have those personal VMs also stored centrally, because then you're not bound to the hardware they're hosted on. Still, 28% is doing local storage for VDI. In many cases, that's then on a shared desktop. Another thing, and we found it very interesting, is, and also because we said it in the beginning, when we did our first primary research on VDI performance tuning, we asked how many virtual CPUs do you use within your desktop VMs? About 55% said, well, we're using one virtual CPU, and 40% said we're doing 2 virtual CPUs. Now, this discussion, this webinar is specifically also about user experience, and it's interesting to see that still so many organizations only use one virtual CPU, and later on we'll discuss this, what the impact of that is. Only a very small percentage considering a higher vCPU count, like 2% for 4 virtual CPUs. But the far majority is still 1 virtual CPUs, and this impacts user experience. So we asked over more than 80 questions. This is just a quick summary of the, well, I think interesting things we found out of the survey. But interestingly, one of the questions that we also ask is, what do you think is important to increase the adoption of VDI and server-based computing in the long run? And it is very, very clear that the top 4 goals or innovation areas are user experience, user experience, user experience, and user experience and performance. So for VDI and for server-based computing, but specifically VDI, to become successful in the long run, we need user experience. Now, interestingly, you know, typically what we see today is that any VDI deployments, the user experience is not completely up to par. I would like to give the word to Chetan for a second to talk about user experience.
Thanks very much, Jeroen, and the wonderful insights over there that you covered from the VRC research. I think when it comes to user experience, people greatly overestimate the challenges around providing user experience, underestimate the challenges around providing user experience. They tend to think that user experience is primarily driven by the remote access protocol. But at the heart of user experience is the storage system. And one of the big fundamental differences between server and desktop architectures is that in desktops, interactivity is driven by user experience. So storage and sizing storage, and specifically the kind of I/O that you need and how many, what IOPS capacity you need, is very, very critical. If you are trying to achieve parity with a desktop PC, like the typical one that you find in retail stores, you'll have to size for about 70 IOPS. On the other hand, if you want to provide a superlative user experience like the one that comes with using Ultrabooks or using a MacBook Air, for example, you have to size for 1,000 to 5,000 IOPS. The big question really is, what kind of IOPS are required and what kind of IOPS are affordable. From a functional perspective, though, these are the things you need to look at. Enabling users with a rich user experience typically means giving them administrative privileges, so they can install applications, they can customize and personalize their desktops. But even more fundamentally, instant indexing is a big part of being productive using a desktop. And so being able to search and use search tools within a desktop are very important. And from a performance standpoint, like I said, storage is the heart of this. You also need to have enough compute to be able to do rich graphics, and also deal with the many agents and management infrastructure that typically runs in a desktop, such as antivirus, inventory scanning, etc. Next slide, please.
Yep.
Yep, thanks.
I'm a clicker.
No problem. There are many best practices that have evolved over the years, and I think the industry in some ways has done us a bit of a disservice, because many of these practices are really results of trying to achieve some sort of compromise between cost and user experience. So really, many of these advocated best practices are really just tips on how to compromise the system from a user experience standpoint, and still make it sort of work. So we've heard, for example, time and again by various vendors suggesting that indexing should be turned off. And you hear this not just from storage, but also from anyone who's sort of written any kind of information around what's the best way to do a VDI. If you're a desktop user, you work on documents. That's one of the prime areas that you focus on, and not having indexing in available to search in your emails, to search across your file system, can be a big impediment. So we tend to think that a lot of the best practices that are in the industry are really a short-sighted approach to solving what are essentially a storage and a user experience problem. And later on during the conversation, we'll talk more in detail about how do you get around that. Back to you, Jeroen.
Yeah, thank you, Chetan. Interesting thing is that we, Project VRC, when I have my Project VRC hat on, actually we talked about a lot of performance tuning, a lot of best practices, and we explained that disabling Windows indexing does have its impact, but we also always explained that yeah, we try for the best user density within Project VSC. We don't see that the performance best practices that we implement are always the best best practices, especially from a functional point of view. So actually what we're going to do right now is do a rehearse of those performance best practices and also new ones. So actually the data that we're going to show right now is a deeper dive into the impact of those best practices using LoginVSI and to see and better understand what the impact is of those performance best practices. To be clear, we're using LoginVSI in the test results that we're showing, of course, in this presentation. The great thing about LoginVSI is that it's a turnkey benchmark load generator specifically designed for VDI and server-based computing. You don't need to create the workloads. And the magic happens when you actually start doing benchmarking. We see that every time in every single project, but of course we see also that in project virtuality check. There's so much to be learned from actually doing performance tests. And the reality is that there's a lot of wisdom and a lot of insights coming out of it. Everybody does it also, of course, in the R&D environment. But it is something that everybody should do. And the reality is that up to now it has been very, very complicated. And what we try to do with LoginVSI is to make it as simple as possible. Well, basically LoginVSI is a workload generator. We simulate users, and we simulate users using common applications like the Office Suite. We review and print PDFs, we do Internet Explorer, we watch HTML5 video, we use Java application as FreeMind. For instance, we also use a bit of Flash. And basically there's a generic VDI desktop workload in there that you can immediately use outside of the, in the box. And within that workload we specifically measure the user experience. We measure the response times of the applications, and that will tell us what the density, what the response time and the set density of a typical VDI host can be. Just to explain a little bit better, I have here a Dutch bus. We'll basically set up a configuration. For instance, we have a specific set of memory, we have a specific set of virtual CPUs, amount of a specific set of desktop VMs. We've configured everything in a specific way. We'll load up VSI users. We start with one, and gradually in 48 minutes we'll load up additional users. And in the meantime we'll measure performance. Basically we'll overload the system. Well, this is way beyond saturation, of course, but we're looking for the moment where users start complaining. So where is the bus still comfortable and how many users are on there? Now the cool thing, if we do this, we can check the configuration, we can redo the test, still see where that limit is. And then out of that we can make comparisons. For instance, if one test we had 100 users and the second configuration had 120 users, we can assume that there's 20% capacity improvement by changing the configuration. And that's actually what you see in this next slides. The result is a VSI max chart. On the left side you see the vertically is the response time. Lower you can see the amount of users being logged on. And this is actually a VSI max response time. So we measure the performance of the application on the system. And you can clearly see up to 130 users the response time was pretty good, but after that they escalated badly. And this helps us to make comparisons. So let's see what kind of discussions there are. Well, we just, in January, this is a very small portion of that white paper, we released an antivirus impact white paper. We did a deep dive of what is the potential antivirus impact. And you have to understand that we already found a lot of best practices, and one of the best practices was to pre-scan the image. So we compared many different products. We compared Forefront, McAfee Move, Symantec Endpoint Protection, McAfee Antivirus Enterprise, Symantec Endpoint Protection, and also we did Trend Micro. The Trend Micro results will be available in an updated white paper. But as you can see, if you're running no AV and you're running, for instance, Symantec, you could see with VSI Max that once we installed Symantec, we lost 21% in capacity, and this is actually a very conventional calculation, because in the real world the performance impact of antivirus is pretty big. Also, we already applied some best practices here. For instance, we pre-scanned the image, but still the performance impact is huge. But it's not just on the overall session density. If you review the I/O impact, you can see, well, depending on what kind of V solution you're using, it could be up to 320% extra I/O they get on the system. So AV has a huge impact on I/O, and I think many organizations underestimate this. Now, I really recommend that you review our antivirus white paper, and if you're interested in the trend MICO, in the upcoming months we'll update the white paper and MICO results. Another very interesting one is, like, a lot of organizations are updating to Office 2013. And one of the things that we found out, and these are still unofficial, unpublished results, is that once you compare Office 2010 and Office 2007, they are identical when it comes to capacity, and they don't have a huge difference in the CPU and I/O. However, once you install Office 2013, expect at least a 15% performance impact, and so you need 15% more hardware. So where's this performance impact coming from? Well, it's memory, it's CPU utilization. You can see the blue line. This, by the way, is ESX information from the test. Is that the blue line is Office 2013 has a clearly higher CPU impact than Office 2007 or Office 2010. But it is also in the I/O, and specifically you can see the I/O is not that much higher, but specifically the write I/Os are high, which is interesting. Office 2013 has a significant I/O overhead. So we want to see if we can tune Office 2013 and do retests, but as you can see the results are a little bit disappointing because, for instance, when we disabled hardware acceleration or disabled animations within Office 2013, it did not improve the overall session density that we can achieve on the same server. So that's the thing that you need to remember. When you're doing Office 2013, it will have an impact, and there's an impact on I/O. Another one is, you see, a lot of people are talking about that Windows 7 64-bit is the best operating system to VDI, but it actually has quite a significant performance impact. What we see is that once you do the same environment, run Office 64-bit, and compare that with exactly the same environment running Windows 7 32-bit, you have, again, about 15% performance impact. So you need more hardware once you start running Windows 7 64-bit. And you can clearly see it has a higher CPU utilization, but again you see also a higher I/O. And this is also a little bit logical because 64-bit Windows has a higher bitness, and as a result of that, simply all the read blocks are a little bit higher. And this is also what you see. The majority of the additional I/O now comes from read I/O and not from write I/O. And also a little bit from write I/O, but mostly from the read I/O. Now, I also refer to this in the State of the Union. You know, the majority of the VDI environments currently use one virtual CPU. So actually, to give users a really good user experience, you probably should give two virtual CPUs. The reality of it is that we're giving a highway with only one lane. Anytime anyone breaks, immediately everyone has to brake. If you have a highway with two lanes, if somebody breaks or you have a problem, you can overtake on the second lane. And almost the same story, of course, when you have one or two virtual CPUs. So we did some testing, and the impact is pretty significant. You have, first of all, we do test with one virtual CPU or two virtual CPU, and you see that overall the session density is radically lower, like 30% lower. So to give a better user performance, you would do two virtual CPUs, but as a result, you would lose capacity by 30%. And actually that makes sense. We tested this with the latest version of LoginVSI, and you have to understand that it's not realistic anymore to give a good performing VDI image with just one virtual CPU. But because the CPU utilization is pretty high in LoginVSI 4.0, you're restricting the overall impact of the workload. So if we compare one virtual CPU, that's the green line, with two virtual CPUs, you see an increase in total processor time. But this is not a true story. Actually, when you compare all the utilization time, so this is the CPU that's only been taken by the VMs, you see a much higher increase. And this actually tells a story. If you're moving from one virtual CPU to two virtual CPU, those extra virtual CPUs will be used, especially for multimedia content, where there's a lot more video to be encoded and decoded again, decoded and encoded again for the remoting protocol, and this consumes quite a lot of CPU. So yes, it will impact overall session density. Yes, users will use more CPU if you go to two virtual CPU. It's very, very important you give the user a much better user experience. Now, a last one that is, well, Chetan already discussed it, and I think it's justified. If I were to work as a consultant in a VDI environment without indexing, that actually is a big impact on user performance. It's horrible to work within an Outlook environment without indexing. So we reviewed the impact in a traditional environment without storage optimization. What is the impact of indexing? Well, just looking at VSI numbers, so we do the VSI test, you can clearly see there's a 3 to 5% performance impact. So that is not completely dramatic. Also, if you look at the CPU difference, it's not that dramatic. We do have a little bit higher CPU average when we enable indexing, that's the red line. However, when you look at it from an I/O core perspective, there's a quite significant impact. You see the total I/Os is much higher for indexing when you enable indexing. Interestingly, it's not in the reads, and this is to me a big surprise. It's actually in writes. And when you enable indexing, you can up to 50% increase the total write I/O. You by far give the user the best user experience, but of course, before you know it, that user experience is degraded because many storage systems have difficulties handling writes. And actually, this is all these best practices, when you enable them, they have you see with many of those practices, they have also a big impact on I/O. So if you want to give the best user experience, you need to make sure that you have a different strategy for I/O. And I think this is a good moment to give the mic to Chetan and talk about Atlantis Elio.
Thanks very much. Thanks very much, Jeroen. That was very, very informative. And as Jeroen clearly pointed out, slide after slide, with some really wonderful insights and some data with there, storage and compute are two of the biggest factors in user experience. And of course, having additional compute can help. Getting additional compute is usually easy. You can buy a larger server, you can add more sockets, you can buy more cores. And from an economic standpoint, it's straightforward to do that. But storage, however, is a completely different animal. Storage tends to be really like the iceberg phenomena, where most of the cost of storage and the complexity of storage is hidden underneath the infrastructure. And for a product like Atlantis, Elio really comes in. Elio is a piece of software that can dramatically realign and transform the way you do VDI, because it solves the storage capacity and the IOPS problem. How it solves those two issues we'll talk about from a technical perspective, but just key benefits. If you are interested in providing a better PC experience, take the fastest, best PC that you can buy in the market, and if you want to actually exceed that in terms of being able to deliver a user experience better than that on a VDI environment, then Atlantis software can let you do that. The other way to do that is to buy a lot of expensive storage, but the benefit that Atlantis does is it rationalizes the cost of storage completely, because it turns the server and the resources of the server, the RAM on the server, into a storage volume that you can run your desktops on. So it actually gives you the ability to do stateless VDI with absolutely no storage. And that's actually a completely new way of thinking of VDI infrastructure. This also gives you now a storage system that can deliver about 300 IOs per user and a cost point of well below $200 for non-persistent desktops. You can also do in-memory storage, which is using the RAM on the server as storage for persistent VDI. And we'll talk about the internals of how that works in a second. But what that now gives you is a cost point of about $300 and the same 300 IOPS utilization. In addition to the storage technology that Atlantis Elio provides, it also has a full set of technologies for deployment automation. So there are visit-driven utilities that essentially allow you to go from A to Z in terms of install, deployment, configuration, and get you through the whole VDI lifecycle in a very short amount of time. And it's one uniform architecture that gives you both persistent as well as seamless desktops with one common architecture and infrastructure. There are no changes. You don't have to do different things to support different classes of users. And all this happens with just software. You don't have to buy a particular type of storage, a particular type of infrastructure. You simply use our software on top of existing hypervisor infrastructure, and you get all these benefits of transforming your storage. So let's talk a little bit about how Atlantis works and what it does. The graphic I have in front of you is really showing you what the Atlantis software does in a very visual way. The software basically takes local RAM, this is the same DDR3 memory that's available on your server, and turns that RAM into storage. It turns it into NFS, file system storage, or iSCSI block storage. That is then fed back into your hypervisor as a data store, and your VMs, your desktop VMs, whether they're stateless or they're persistent, run on that NFS iSCSI data store the Atlantis Elio software provides. And the blue graph over there depicts the I/O generated by the VDI VMs. And there's a tremendous amount of I/O that happens as VMs boot up, as users log in, launch applications, and there are many background services that run that are doing the AV scanning, that are doing the inventory management, et cetera, for the day-to-day management of this PCs. The red graph now actually shows you the Atlantis Elio's value in this I/O path. It transparently it transparently optimizes all the I/O requests that are generated by the VDI VMs, and literally cuts out 90% of the I/O noise or chatter that is generated in a VDI environment. And just the remaining 10% stateful data is actually stored on server RAM. So as a result, you can amplify a small amount of server RAM into looking like a very large storage system. In general, you can take about 80 gigs of server RAM and make it look like 2 to 3 terabytes of virtual storage for VMs. How does that work? We'll talk in a second. So the Atlantis software is inline between the VMs and what it looks like storage. Essentially, the RAM is turned into storage. And it applies 5 critical transformations to the I/Os that are on the I/O path between the storage and the VMs. So let's talk about what those 5 critical transformations are. The first one is Atlantis' patented script sauce that we call application analysis. The Atlantis engine is a storage engine that is content and context aware. Most storage engines simply, are block engines that service read or write requests. The Atlantis software actually understands what each and every I/O being generated by each VM is. So I'll give you an example. If there are 2 users and user A is launching an Excel file, which is very large, you really want that file to launch as quickly as possible. You want it to be an instantaneous experience. Meanwhile, user B is working on an email, and in the background, there's an AV scan that's running. Now, in this case, you really don't care if the AV scan takes a few seconds for it to complete. If you had a conventional storage engine, it simply sees a bunch of read requests coming from both VMs and does not know how to prioritize the Excel launch, which is a user experience intensive situation, versus the AV scan. And so, that's where the conventional storage model starts to fall apart and where the user challenges with conventional storage start. Well, the Atlantis software has this real-time prioritization. It's able to look at millions of I/O requests across all these virtual machines and make these deep optimization based on the type of I/O request through this application analysis. Coupled with that is this idea of content-aware I/O processing. Block-level engines, again, have very little knowledge around what is going on inside a VM. I'll give you one simple example. When you launch Microsoft Word, a block-level engine simply uses temporal or spatial locality of reference to sort of go into a prefetch. The assumption is if you requested block number X, then you will probably also request block number X plus 1 and X plus 2 at some point in the future, so let me just go ahead and bring those into memory. The problem you have in virtualization is that every VM has its own logical set of blocks, and there is no necessary guarantees that sequentially adjacent blocks actually belong to the same VM. And so a lot of overhead is lost in a conventional storage system because of things like prefetch. In fact, you can actually improve performance of your VDI by turning off prefetch. Now, in Atlantis' case, because we're content and context aware, we can actually recognize launches of specific types of activity. For example, if we launch an application, we know what the payload of the application, for example, Microsoft Word is, and as a result, we can guarantee bandwidth resources to service that entire set of transactions, not just that one immediate block request. So this application analysis, I/O processing, two very, very intelligent content and context-aware approaches to servicing the I/O. Between them, we can cut essentially about 95 to 97% of all I/O requests that typically go and hit a storage system. So just from the ability to offload read requests, these two transformations eliminate most of the read requests from hitting your storage system. Next, the ability to transform the write requests. And really, this is where there are very few answers in the storage industry. How do you transform write requests? One of our key approaches is to use a patented form of inline, real-time, on-the-wire data duplication. What we end up doing is we end up in real time, as the I/O requests are on the wire, picking off duplicate I/O requests and removing a data payload attached to them. And this has two benefits. Number one, it cuts the write traffic and removes the need for that write traffic to be serviced from the storage. It simply gets serviced in RAM on the Atlantis appliance itself. And number two, any data that is written to storage is always deduplicated, single instance, and then written down. So it takes the optimum amount of storage footprint on the storage end itself. So the inline deduplication really results in about 85 to 90% reduction in the write traffic that goes to the storage system. So if you take the first component, application analysis, I/O processing, that is reducing your read request by 95%. You take the inline deduplication, which is reducing your write traffic by about 80–85%. There's already a dramatic reduction in your storage needs between these two. You don't have to buy fast storage. You don't have to buy expensive, flashy storage. And neither do you have to buy large amounts of it because you're getting a single instance function. Now, the Atlantis software actually takes local storage and turns that local storage, it takes local RAM and turns that into storage. And before it puts VMs on that storage, it deduplicates it and then compresses it further. And the reduction through our combination of deduplication and compression is quite dramatic. I'll give you one example. You can take a 60 to 80 gigabyte persistent desktop image and store it in 1 to 1.5 gigabytes of RAM. That's the incredible amount of compacting that happens in the way we do our deduplication and compression of that image. So as a result, 100 gigs of memory can give you more than 100 VMs, persistent within a deployment. The last piece that we have is a concept that we call fast replication that constantly takes the contents of the RAM and synchronizes it to storage. So as a result, you get RAM performance, but you get the durability of storage because everything that's on RAM is backed up down to storage itself. So if you lose power on the server, you might lose the contents of the RAM, but the persistent desktop contents are always committed down to storage, so you never actually lose any data. So now we go to the vital question, user experience standpoint of asking, how many IOPS are enough? As I said before, if you wanted to get a user experience that's on parity with an average PC, and if you went and asked the user, how they felt about the average PC, I don't think you're going to get any large, gushes of enthusiasm. They'll probably tell you that their PC works and it's okay. They're not going to necessarily tell you how much they love their PC. On the other hand, you've got a spectrum of users who love Ultrabooks, who are very passionate about the user experience that they get, for example, from a MacBook Air. And that's really because the user experience is so instantaneous. It basically responds to every touch, every click, as quickly as possible. And from a storage perspective, that's because there's usually some sort of flash storage locally available to that device, and that flash storage can do about 5,000 IOPS. So you have to pick a spectrum between these two for your virtual desktop to get somewhat of a usable user experience. But the challenge we have is, in the storage industry, we've been told that 15 to 20 IOPS is good enough for your desktop. And that number really came out of an averaging function where people measured the IO that was used by a desktop and then averaged it over a 24-hour period, over a 7-day period, whatever that might be. And the challenge with averaging is that there are many periods of inactivity in a PC. And if you size for your average, the peaks which are generated during logon or during some of the activities that Yaron earlier mentioned can just be so high that the differential between the average and the peak just makes you pay the penalty for IOPS across the entire day rather than at specific intervals. So before we answer how many IOPS are enough, let's take a look at what the typical IOPS generated by the most common applications that are run on a user's PCs. So, we basically sampled at the I/O level launch times and as well as the kind of IOPS that are consumed by different applications. And what we found was quite interesting. We found that on average, applications consume between, generate between 975 to 1,000 IOPS, I/O operations, as they launched. For example, Outlook consumed about 975 IOPS and Excel about 3,700. So if I had, for example, on this virtual desktop, some sort of storage that had 1,000 I/O operations per second capacity, that Outlook would just launch in just under a second, whereas Excel would take about close to 4 seconds. What's interesting is the Windows update, at its peak generates about 4,000 IOPS. But if you look at the area under that graph, you're looking at more like 40 to 50,000 I/O operations per second being generated by that Windows update. Then finally, I want to bring your attention to the Windows 7 idle phase, which is right at the end. And even when the system is idle, it's generating at a peak about 2,000 IOPS. It's a very good reason as to why it's doing that are internal to Windows architecture. But from a storage sizing standpoint, it's very hard when you look at this graph to ascertain how do I size my IOPS. But I'll tell you this much. If you're sizing your VDI at 15 or 20 IOPS, each of those operations is going to take several tens of seconds, several minutes to complete. If you look at the total range of IOPS that were consumed in this, we're looking at a magnitude of about 200 to 250,000 I/O operations total. And so if you're sizing at 20 IOPS per capacity, you're talking about not having enough time in a day, really, literally, to be able to service all these I/O requests. The final point I'll make on this is that there is a collusion of IOs that typically happens in a VDI environment. Even if just 10% of your population started to do a Windows update at the same time, you're talking about a collusion of about 40,000 IOPS, or 50,000 IOPS, 100,000 IOPS that can essentially soak and saturate your storage system, thereby eliminating any ability to service any of the I/O requests that are coming. So net-net, sizing for average I/O is a recipe for disaster, and I would highly recommend not sizing for average I/O, but to instead look for a solution where I/O is not the problem. So what is that? Well, there is one way that you can look at storage and say I/O will not be the problem, which is to essentially try and have a situation where you have unlimited amounts of I/O, or more I/O than you can practically plan to consume in a VDI environment. And you do that by using RAM as primary storage. And what's interesting about this solution is that regardless of the limitation of RAM as a volatile medium, the Atlantis Helio software constantly backs this up using fast replication, and as a result gives you complete durability. You can use this for persistent desktops with or without profile redirection. You can actually use a local profile and have users commit all their data, their documents, etc., into RAM, but this is constantly backed up down to storage. And this gives you a two-dimensional benefit. All the performance comes off the RAM tier, whereas all the durability comes off existing storage tier. Very, very fast. And as a result, your user experience is better than a MacBook Air with SSD, and there's empirical data to show this. On average, the boot time of a Windows 7 VM is under 15 seconds, about 12 seconds. App launches are instantaneous. Before you can take your finger off the mouse, the app is already launched. And best part, you don't have to tune and optimize the image anymore. You can simply turn on all the typical defaults that you provide on a PC to enable the best user experience. It's the way Microsoft wanted you to consume a Windows desktop, and that's what this technology really enables. And from an architecture perspective, this is what it looks like. You have a copy of the Atlantis software on each hypervisor host. This is the VDI environment where the desktops are running. And as each VM generates I/O, it's serviced locally off RAM. In the background, another Atlantis server, which is another virtual machine, simply takes the copies of everything that's in RAM, processes that and makes a commit down to storage. So between these two systems, between the Atlantis Helio on each host and the Atlantis Helio that's on the replication host, you get complete performance as well as durability down to the storage system. And your storage is simply sized for the deduplicated, reduced capacity that you require. You don't actually size it for the full capacity. You only size it for about 10 to 15% of the capacity that you need to store those VMs. And the backend storage really has no role to play in the runtime performance. And as a result, you don't really need to have fast or expensive storage in that tier. And from a persistent desktop standpoint, high availability is obviously a big deal since you can't really redirect users away if you have loss of a server, etc. So the software comes with automatic high availability built into it. So if you lose a VDI server, for example, you can automatically relocate the Atlantis software as well as all the desktops onto a failover blade or failover host, and the same thing can be done with the replication host as well. So you get all the benefits of having a fully redundant architecture, being able to service big, fat, persistent desktops or stateless desktops, all from memory, with guaranteed consistency and performance. So we'll do a quick comparison. We used Login Consultant's VSI tool to actually index the performance of the Atlantis in-memory storage. But to just give you a comparison, this is a reference architecture that has been published and is available on Citrix's site, and this is for about 2,000 users. And if you see, it really starts to, stretch the limitations of the system at about 1,900 IOPS. This particular benchmark was done with a storage system that had 96 10K SAS drives. So this is, enterprise class storage is pretty expensive. It also has quite a bit of flash in it. It's got 256 gigs of flash memory. And what you'll notice is even with 100 desktops, you're treading the 2,000 line, 2,000 millisecond response time line. Now I want to compare this with Atlantis Ilio in-memory storage power VSI index that we've done for a subset of these VMs, which is about 750 users. And you'll notice some things right up front. Number one, when you start off with about 200 users, so if you sort of look at the x-axis on our 200 user mock, we're still hugging the 1,000 millisecond average response time line. So the user experience is fantastic. Even when the system is fully loaded at 750 users, you're not seeing a vast differential in terms of performance. Extremely stable, scales very, very linearly. And here's the best part. It's only got 9 storage disks underneath it. It's got 9 15K drives, unlike the previous one which we're comparing with, which had 96 drives in it. And this one has no flash cache or no form of flash at all. So user experience is guaranteed, and you can scale very, very well as you add more and more users. And this is with 500 users on a VSI medium with Windows indexing turned on. Again, as you can see, we're hugging that 1,000 line throughout the test, and the average response at the end is about 1143. Really, really consistent, high user experience quality being delivered over here by using RAM as storage. So, Jeroen, I'd like to hand it back to you for you to give us a perspective on, how do you get this virtual desktop that is better than a PC?
Yeah. Now, the cool thing is that there's many discussions about VDI. It was all about the pricing of the infrastructure that is in your data center. They were just used. But ultimately, one of the key obstacles for VDI adoption was that the user experience was not that great. And actually, you could see in the State of Union survey that user experience is the key driver for VDI, and it's still considered the most important driver for the virtual desktop environments. Now, interestingly, if you look at that, and then there were many things that you would do to get a maximum performance or higher density. You would choose shared VDI instead of persistent VDI. You would disable search instead of enable search. You would restrict performance and tune the hell out of the VDI image to reduce the impact of storage. And now you can really change that. Also, if you look at application performance, it's not only VDI, it's also about user experience, also, for instance, with related, of course, to the CPU power available. So 2 virtual CPUs is now the standard, but it will give you great user performance, especially if you use these graphics acceleration cards that are available today. Well, antivirus has a huge performance overhead, so people were either not deploying VDI or they will get a bad performance. And now, especially typically what you see is if you really address the I/O problem, for instance with Atlantis Ilio, you can do safe VDI with full antivirus, and it's not a big of a problem anymore. And interestingly, all the things that we stated today, everything that we researched, all the key findings are done because we're actually now able to validate and test this stuff. It's no more guesswork. You can really get not just results, but interesting results, because you can make comparisons. You can evaluate the size and capacity of your system. And it really makes a change, and it really ultimately gives also a very good user experience. So to wrap up, there's, could you go to the next slide, Chetan, please? Yeah, thank you. So there's a lot of things that we'd like to share with you. If you want to check out what Atlantis have done, they set up the crazy fast VDI desktop in which you can review the ultimate performance you can have with Atlantis. If you want to learn more about Project VRC, just go to our website, to the Project VRC website, register there, and you can download all the white papers that we've published so far. If you're interested in doing your own benchmarking and own load generation and see what's possible, you can download a specific version from LoginVSI.com. Use the code, registration code ATLCOM13. It's available for 2 weeks, so please do that within 2 weeks, and you will get a 2-month pro user license with 100 users, so you can really fully explore the possibilities of load testing with LoginVSI. Review Brian's meta blog on persistent VDI, in-memory storage user experience. Check it out on the Elio performance URL, and of course there's also a more expanded podcast on VDI podcast. I have nothing more to add. It's just that, you know, we've been always talking about VDI, that it is a you know, for end users a limited environment, and I think it's safe to say VDI has now become maybe the best user experience in many cases. I have nothing more to add. Chetan, do you still want to add something to this discussion?
Yeah, sure. I just want to add that Brian Madden's actually written an updated edition to his book, The VDI Delusion. It's called The New VDI Reality. And Brian, many years back, had pointed out the many flaws in VDI, and you know, user experience was obviously a very big deal of that. But what's interesting about the new VDI reality is he talks at a technical level as to how the evolution of technologies, you know, especially like the ones that we talked about from Atlantis, the Elio software, have enabled a new VDI reality where, you know, VDI now makes sense for the vast majority of use cases for desktop out there. So, you know, I encourage everyone to get a free copy of the book, which has been sponsored by my company Atlantis as well as Devon IT.
Thank you, Chetan. With the remaining time that we have about 8 minutes left before the end of the hour. We're going to open it up to questions. So if anybody has a question about any of the content in the presentation, please insert it into the questions box. We have some questions already, so I'll get started. Yaron, the first one, you know, most of your data was around Windows 7 desktops. So we had some, could you give some background on how it differs from, you know, Windows XP, which, you know, a lot of people still are migrating from Windows XP, and also Windows 8 and any of the research you've done on that? Just give a quick summary.
So, well, we still see at least a lot of Windows XP out there. If you want to get all the details, I recommend you go to the Project VRC website and download the Phase 3 white paper. It also explains on G6 hardware how the differences are from I/O CPU capacity and what you can expect. What we think is overall very interesting is when you tune Windows 7 and when you disable scheduled tasks and stuff like that, a lot of those best practices are actually, you know, when they're purely storage related, you can wonder if you still want them, especially when you're running IDO. But they are very, very similar. Windows 7 is nowhere as near as bloated as Windows Vista, and we see also during application runtime that in many cases even the I/O is even better for Windows 7. So if you don't do any performance tuning, expect that Windows 7, especially in the classic environment without storage acceleration like Elio, it has a much bigger impact and results will disappoint. So it's recommendable that you review the white paper. There is an overhead for Windows 7, but if you tune it, it is very minimal. Yeah.
Okay, thanks. And I'll also point out there's a white paper available on the Atlantis website by Jim Moyle called Windows 7 IOPS Deep Dive, where it does some comparison around Windows XP and Windows 7. Next question is for Chetan. Chetan, can you talk to whether Atlantis requires an agent inside the guest VM or how it interfaces to the guest VMs on the server?
Sure. So the interesting thing about the Atlantis software is that it requires absolutely no modifications to either the guest or the hypervisor. It does all its optimization simply by providing a NFS data store on which the VMs are stored and, you know, conduct their active I/O on. So the analysis that we talked about, the application analysis, all of that is done on that NFS stream, and therefore you really don't need any agents, any kind of changes to the image. It simply works transparently as the underlying data store, and it does all that fingerprinting technology that we talked about as a part of that architecture.
Okay, thank you. Next question is for Chetan again. Does Elio make sense when you have larger base images, like 50 or 60 gigabyte images? Can you apply the architecture you talked about in memory with that type of an environment? And what do you see as kind of the customer image size used with Elio?
Great question. In fact, the technology has been built around an average desktop model of being between 60 to 80 gigabytes in size. So I don't consider that a very large image. I consider that an average-sized image. And yes, it absolutely makes sense to take those size of images and put them in memory. What we're able to do is turn about 100 gigs of physical RAM into a data store that can power about 100 to 150 desktops, depending on the amount of unique data, user data that's in there. There's a great deal of redundancy in a VDI environment, especially at the image level. The operating system, the applications tend to be the same. And even with user data, there are great elements of redundancy even within user data, because most people share the same kind of documents that are collaboratively edited, et cetera, within a company. Also, applications don't tend to be unique. They exploit the same underlying Windows, SDKs, DLLs, et cetera. And so we take advantage of all of that with our in-memory technology. And so we can take what look like very large VMs and store them on a very small footprint of RAM.
Okay, so one of the follow-ups to that question was around kind of the typical size of RAM in a server that you would see with a large image environment like that. So are we talking 256 gigs of RAM or 384 gigs of RAM, or what's kind of the RAM sizing there?
So, the range goes from a server with 192 gigs of RAM that can give you about 50 desktops per use on a server. And then at 256, that density bumps up to about 80 to 90. And then if you have 284 gigs of RAM, up to up to half a terabyte of RAM, you can really get about 120 to 140 desktops. Now, once you get to that 384 gig of RAM per server, you really are starting to be, operating at the natural CPU, hard limits. You're no longer gated by memory or storage. You're really gated by the amount of CPU that's available on those servers. But those are sort of the average densities that we have seen with this technology now being deployed for, close to 100,000 desktops, 150,000 desktops across hundreds of customers already.
Okay. We have time for one more question. So, Chetan, there's one more question around, can you use Atlantis Elio in like server 2008 R2 workloads, like as a database server or other general purpose server workloads? How does that work?
Yeah, sure. So very quickly, the current generation of the Atlantis product, the Elio, is really tuned towards VDI and desktop-like workloads. There is a server product available that is specific to XenApp and RDS. However, later this year, we're going to make available our Atlantis Elio for virtual servers, which is targeted specifically at I/O and storage-intensive server applications like databases, as well as a lot of storage-intensive applications like SharePoint, et cetera. So, and it tends to be a more horizontal approach, which works for virtual servers that are based on Windows as well as based on Linux. VDI today, as you know, is exclusively Windows, I'd say. So the current technology is very much geared towards VDI, but in Q4 this year, technology will be available for virtual servers as well.
Okay. Yaron, one for you. Can you give us a quick overview of how the workload has changed, or in some of the new aspects of the LoginVSI 4 that recently was released?
Yep, sure. The LoginVSI 3 workload was actually designed already in LoginVSI 2. It's been around for like 4 years, and we decided to modernize it. So the key changes are that short, it's that the loop that is typically repeated every 12 minutes once a user is logged on is now 48 minutes. It's being segmented, and there are some tricks that make sure that the load is equally distributed. The data set is dramatically increased. So we went from a 300 megabyte to a 20 gigabyte data set. So there's a lot more data being used. That makes it also much more realistic. We also changed the application set a little bit. We still support every single operating system and every single version of Office. But for instance, now we included HTML5 videos because currently HTML5 has become the standard for video play. So the overall workload is about 20 to 30% higher in CPU, but also because the application starts are now more distributed over time. The I/O itself is now reduced a little bit, so I/O is about 20% to 30% lower new LoginVSI workload. The ultimate goal was to make it much more realistic. We talked to everyone in the industry about this, and ultimately that has been achieved. So as a final comment, we think that now the new medium workloads are designed for 2 virtual CPUs, but of course there are already other workloads also in there, and there will be many additional workloads that you can use off the shelf to maybe, if you don't want to play, for instance, HTML5 videos, the workloads will become available. Yep.
Okay, thank you, Jeroen. There was one question. I'll just make a quick comment about reference architectures that are available. We have many reference architectures available at www.atlantiscomputing.com under resources. There's a whole tab with all of them. Most of them include LoginVSI charts and benchmarking, as it's kind of the industry standard for doing the reference architecture. So we, in almost all cases, use LoginVSI as the benchmark for that. So please check out some of the reference architectures. I believe LoginVSI also has posted them on their website under the reference architecture section. And we have both architectures for persistent VDI and stateless VDI, different types of servers and configurations. So with that, we're at the end of the hour. So I'd like to thank Chetan and Jeroen for the great content they presented. If we did not get to your question, we will follow up individually with you. And thank you very much.